You're going to add, subtract, and multiply polynomials. Obviously, adding and subtracting is easier than multiplying. So adding, subtracting, and multiplying polynomials. The difference in this and what you did in Algebra 1 is absolutely nothing. It is exactly the same thing you did in Algebra 1 when you add and subtract and multiply polynomials. All the rules are the same. We're putting like terms together with addition and subtraction. And when we multiply, we got to simplify and put it in descending order. And that's going to help us build up to the goal of Chapter 5 is to take polynomials and solve them much higher degree polynomials than quadratics. So those things from quadratics don't go away. We still got to be able to use them, but hopefully we get better at them as we go along here. So instructions are going to be simplify or find the sum, find the difference, find the product. They all mean the same thing. It means work out the problem, get the like terms together, and write your answer in descending order. That's what it means. So we'll start with something pretty easy, like x squared plus 3x minus 5 plus 3x squared minus x plus 7. Now, those parentheses that are there are not necessary, but the idea is that we're adding and subtracting polynomials. So I'm kind of trying to force that and say, okay, here's a polynomial plus another polynomial. It's like two separate polynomials that you're adding together there, but it's just like terms. So we're adding x squareds to x squareds. So when we put this with this, what's x squared plus 3x squared? 4x squared. And then 3x plus negative x. 2x, yeah. And then negative 5 plus 7. 2. And then you check it to make sure it's in descending order, because we're going to need it in descending order later on in the chapter. So just get in the habit of putting it in there now. So squared, plain x, no x's, that's in descending order. We've added a couple polynomials together. Again, nothing different than what you've done in the past as far as adding, subtracting polynomials. Just got to, maybe it's a little higher degree this time, higher exponents. So this 3y to the third minus 2y squared minus 7y. That's one polynomial. Let's add it to another polynomial, negative 4y squared minus 5 plus 2y. And purposely not in order there. Okay. So anytime I'm doing this, I'm always looking for what's the highest exponent on the variable and start there and then go down. That way, when I get done, I don't have to rearrange stuff. I've done it in order, so I know it's in order when I get finished. So what's the highest exponent on the variable? The y to the 3y to the third. So are there any like terms with 3y to the third? No. So what do I do with that? Just bring it down. So that guy's done. And you can mark them out if you want to. You don't have to. Sometimes it helps just kind of simplify things. And then after y to the third, the next obvious one in descending order would be y squared. So you try to put your y squareds together. You've got a negative 2y squared and a negative 4y squared. Together would be negative 6y squared. Good job. And then the next descending piece would be the y's. So you got negative 7y and positive 2y, negative 5y. And then the last piece is that lonely little minus 5 just there. And it's in descending order because I did it in descending order. I don't have to rearrange it at the end. Just saves you a little headache there at the end if you just do it in order as you're going there. So addition, find the sum, simplify, any of those words do the same thing. Put the like terms together. It's just adding, subtracting polynomials. This should be cake on that part. 5y squared plus 6y plus 7 minus 3y squared plus 8y minus 6. So when you start throwing negative signs in there and minus signs, that's when folks tend to make mistakes. But don't overthink it. I mean, it's just subtraction. So you know that whatever's in front is subtracting. You subtract whatever's after the minus sign. So it's 5y squared minus 3y squared, which is 2y squared. And then you got 6y minus 8y, negative 2y. And then we have 7 minus negative 6, 13. So that's doing it without distributing. If you wanted to, you could, like distribute this negative sign to everybody and just change their signs and then do the problem. It's exactly the same work. It's no different. I don't do that. I used to do that every time, but found out it really doesn't help. Most folks, if you're going to miss it, you'll miss it anyway, even if I tell you to do that. So, I think if you just think, okay, it's subtraction, so just got to remember to minus, and I'll be okay. Let's do another one of those. Then we'll get to the fun part, the multiplying. 6y minus 8y squared plus 11 minus negative 6y to the third plus 4y squared minus 8 plus 10y. A little bit bigger problem here, but still the same idea. So thinking, okay, now I got to go in descending order. In the first polynomial, there's y squared. That's the biggest one. But in the second polynomial, there's a y cubed. So the y cubed is the biggest piece. But what kind of 6y cubed is that? It's negative, but it's inside of subtraction, so it becomes positive 6y cubed. And that's one of the most common mistakes is that double negative there, not changing that to a positive. So we have positive 6y cubed. And then we can just go through the subtraction stuff from there with the like terms. So we've got negative 8y squared minus 4y squared would be negative 12y squared. Yeah, good job. And then 6y minus 10y. 6y negative 4y. And then 11 minus negative 8, positive 19. And there you've added or subtracted or found the difference of that, those two polynomials. That should be the easiest thing we've done in quite a while, probably. Very, very, very simple idea. All right. Any questions about adding, subtracting polynomials? Good deal. All right, let's move on to the next part, the multiplying. So find the product. We'll start with something very Algebra 1-ish and very quadratic in nature. It's the factored form of a quadratic, and they want us to find that product. So they want us to multiply this thing out and make the bigger polynomial that this comes from. So if we're going to multiply that out, depending on who you had for Algebra 1, if you had me, I don't think I mentioned anything about FOIL method. If you had Coach McLean or Coach McElmore or Coach McGee, you might have heard the word FOIL method. It doesn't really matter. It's distributive property no matter which way you do it. You're just distributing x plus 4 to 3x plus 5. And the way I always just do, I just go x times 3x and x times 5. That'd be 3x squared plus 5x. And then I go distribute the 4. That'd be plus 12x plus 20. And then you look to see if there are any like terms. Are there? Yeah, those two in the middle there go together. So that'd be 3x squared plus 17x plus 20. And you've multiplied two polynomials. Technically, they're binomials in this case, but it doesn't really matter. You're just multiplying. 2x minus 5 and 5x minus 7. Do another quadratic there just to get the practice with it. Do your distributive property twice. That's all it is. Nothing more complicated than that. So the first term would be what? 2x times 5x, which is 10x squared. And then the second term would be negative 14x, and then distribute the minus 5. So that's negative 25x plus 35. Combine your like terms and you're done. 10x squared minus 39x plus 35. So distributive property is all this is. It's really nothing. What does this mean? Does it mean to square something? Yeah, just two of them and multiply them. Yeah, that's right, guys. Good job. And then multiply that. Now, there are shortcuts to doing that. If you've done enough of them, you realize, oh, the middle term doubles, and it's, but if you don't, I mean, it's still not that long to multiply it out. X times x is x squared plus 7x, and then distribute the 7, so that's 7x plus 49. And that middle term is 14x, so x squared plus 14x plus 49. It doesn't take that long to really just multiply it out step by step. The shortcut is that you square the first term, and that's in front. You square the last term, that's in back. Then you multiply them together and double it, and that gets you the middle term. 7x times 2 is 14x. That's the shortcut to squaring a binomial, but by the time I told you that shortcut, we could already just multiply it and be okay. So if you do the shortcut, great. If you don't, it's no big deal. You can still just like the biggest things, are you getting the right answer? All right. So squaring it, 2 of them, cubing it would be 3 of them, and you multiply it out, and we'll get to that in just a second. So let's do this one. Y minus 2, parentheses, negative 2y squared plus 3y minus 6. So we're getting to larger polynomials. Everything up to this point has been quadratic on the multiplying. So we're going to get to something that's cubic or third degree when we get here. Nothing changes, though, in how you do it. You just can't call it FOIL method anymore, because FOIL method only works for binomial times binomial, two terms times 2 terms. This is just distributive property, and you distribute y minus 2 to all of that. So I'm just going to distribute y first, and whether you draw the lines or not, I'm just doing that for notes purposes. So that's negative 2y to the third plus 3y squared minus 6y. Okay, that's distributing the y. Now I'm going to distribute the minus 2 to everybody. And one of the tricks, or I guess methods that I use here, is stacking it instead of writing it all out really long. If you stack it, you put your like terms together a little easier, because negative 2 times negative 2y squared is going to be positive 4y squared. So if I'll stack that underneath the like term, then I can just put it together maybe a little easier, quicker. Now that, come on in, Miss Peggy. And then negative 2 times 3y, that's another negative 6y. And then negative 2 times negative 6 is positive 12. That really will be helpful when we get to like a trinomial times a trinomial. Stacking it keeps it from, because if you get trinomial times trinomial, you got like 9 terms at the end, and if you got them stretched out across the whole page, it's easy to mess up. But if you stack them, it seems to organize it and make it a little easier to do. So negative 2y cubed, 7y squared, negative 12y, and then 12. And there is our nice cubic polynomial out of that. Not too difficult. Let's go a little bit more fun. X squared minus 4, so we got a quadratic piece, times 2x to the third plus 3x squared minus 5x plus 1. So we've got, is this problem any different than the previous problem? No, it's just got different exponents. That's the only difference. So when we multiply x squared times 2x to the third, what's that end up being? 2x to the fifth. Yeah, good job. And then just follow that pattern. X squared times 3x squared would be 3x to the fourth, 5x squared, or to the third, excuse me, and then x squared. And then distribute the minus 4 to everybody. So that'd be negative 8x cubed. So I'd go under here. And then negative 12x squared, positive 20x, and then minus 4. And then just put the things together that go together. 2x to the fifth, 3x to the fourth doesn't have any like terms, and then we got a negative 13x cubed, negative 11x squared, 20x, and minus 4. Stacking them up. To me, makes it a little bit more organized, a little easier to put it together. If you don't do it that way, I'm not saying you got to do it that way. I just been doing it that way for the last few years, and it seems to help a little, maybe. All right. Fun stuff so far. Let's go to x plus 3 cubed. What does it mean to cube something? Multiply it by itself 3 times. So x plus 3 times x plus 3 times x plus 3. Now, you don't want to do all 3 of them at once, because that's where mistakes happen when you try to do too much at once. So pick 2 of them to work together first. I'm a right to left kind of person, because it makes sense to put those, to my brain, to put those 2 together first and then distribute x plus 3 to that answer. So that's how I do it. It doesn't matter which 2 you pick to put together, though. You can do these 2 together. You can do the first and the last together. It doesn't matter. They're all the same anyway. So when I multiply x plus 3 times x plus 3, it's going to be x squared plus 3x plus 3x plus 9. Go ahead and simplify before you multiply again. That's where a lot of people don't do that, and it makes your problem even longer than it already is. It's already a pretty long problem, so make it shorter before you multiply again. And then, now you're just distributing x to everything and 3 to everything. That's going to be x cubed, 6x squared, 9x, 3x squared, 18x, 27. Put them together. And there we have that cubic polynomial out of that. One of the goals that we're going to be working toward in Chapter 5 is right now we're going in this direction. We're taking stuff and multiplying it and adding it together to get a bigger polynomial. Later on, we're going to take the bigger polynomial and start breaking it down until we end up with something like that. And so we can get the zeros of it pretty easily. So working in both directions in Chapter 5. All right, so we got 3x squared minus 5x plus 8 times a negative 7x squared plus 2x minus 9. Don't really get much bigger than trinomial times trinomial. So 3 terms times 3 terms. How many distributive properties are you doing? 3. That's all it is. It's nothing. This is not anything. So I'm distributing 3x squared to everybody. It'd be negative 21x to the fourth, 6x to the third, negative 27x squared. And then I distribute the negative 5x to everybody. That'd be positive 35 x to the third, negative 10x squared, positive 45x. And then last, distribute the positive 8 to everybody. Be negative 56x squared, positive 16x, and negative 72. Definitely stacking is, I think, helpful on this. And just add your columns together. You got 21, negative 21 x to the fourth, 41 x to the third. Good thing is they're all negative there, so we just total them up. So that'd be 66, 86, 95. Is that right? Hold on, 66, 93. 93, yes. Negative 93. Yes, I will. (93x squared), and then that'd be 61x minus 72. And we have a fourth degree polynomial here. And yes, eventually we'll get to where we can break that down at some point in the chapter here. All right. Nothing really complicated about this at all. Any questions about it so far? Say so far, I'm done. All right, so short lesson today. This will be the first lesson with quiz and all for quarter 2. Okay, quarter 1 grades are no new grades for quarter 1. All right. So a couple of sections that we addressed there. Page 333, we're going 24 through 35, not a whole lot there. And then page 349, 3 through 45. Odd only on that page 349. Okay, so that'll get us the addition, subtraction, and then multiply. Hold on, back up. Mark off that 333. Kill that. Let's just do 3. That 340. Yeah, that is just mattering the addition, subtraction, and multiplication. 349, 3 through 45. Okay.